Alrighty guys, to start today's class, we're going to do a review from yesterday. Number 1 says, identify the independent and dependent variable in each situation. The cost to gift wrap in order is $3 plus $1 per item wrapped. Again, the two things that are changing are the number of items and your total cost. So you want to ask yourself, does the total cost depend on the items or vice versa? And I would say this. So you know that your dependent variable is your total cost, and your independent variable is the number of items. So number 2 says to evaluate each function for the given input values. So we have f of x equals x squared minus 5. Find f of x when x equals 0 and when x equals 3. Again, remember when you substitute, put it in parentheses. So we have f of 0 equals in parentheses 0 squared minus 5. First do your exponent. 0 times 0 is 0 minus 5 equals negative 5. So this isn't your answer. 0 comma negative 5. This is your answer. How about when x equals 3? Plug it in. F of 3, plug in your 3, equals, in parentheses, 3 quantity squared minus 5. 3 squared is 9 minus 5 gives you 4. So your ordered pair is 3, comma 4. Now we need to write a function rule for the given table. How do I get from 1 to negative 3? The same way I get from 2 to negative 1, same way I get from 3 to 1, the same way I get from 4 to 3. This one's kind of hard. I can't think of any. Well, 1 times negative 3 is negative 3, but that doesn't work for anything else. 1 minus 4, 2 minus, no. Division, I can't think of that. Remember your g of x is your y. So let's go to a big one, 4 to 3. What can I multiply 4 by that gets me close to 3? Well, what about, instead of multiplying by 1, what's 4 times 2 equal? Well, that equals 8. How would I get to 3? Then I subtract 5. And that would give me my 3. Let's see if that works for the 3. What's 3 times 2 equals 6? 6 minus 5 is 1. 2 times 2 equals 4. 4 minus 5 equals negative 1. 1 times 2 equals 2. Minus 5 equals negative 3. We found it. It was times 2 minus 5. So g of x equals 2 times x minus 5. That one was a tricky one. Well, now today we know how to write them. We're going to go ahead and we're going to graph functions. So your learning target is I can graph a function with or without a given domain. The first way we're going to do it is with a domain. So now we have a domain and x values are given. There's 5 little steps. The first one that you always want to do is you want to rearrange your equation to y equals something, or f of x equals something. Always rearrange it. After you do that, you're going to make a table where your x values, well, your domain is your x, so your x values are your domain. Step 3 is to plug in x and simplify. The next one is to write as ordered pairs. And what do you always do with them? And plot. So after you plot them, guess what, guys? You are done. Just ordered pairs, just ordered pairs, just ordered pairs. That's really important. So let's go ahead and do this with number 1. I left the instructions up there. It says graph each function for the given domain. Remember, these are my x values. Step 1, rearrange so it's y equals. Here I have x minus 3y equals negative 6. So I want to solve for y. I'm going to circle it. It's a positive x, so I have to subtract x from both sides. So we have negative 3y, don't forget your sign to the left, equals negative 6 minus x. Then again, we still need to solve for y, so we have to divide both sides by negative 3. Both sides by negative 3. So when I do that, I'm left with y equals, remember you can do each individual one, negative 6 divided by negative 3 is a positive 2, and negative x divided by negative 3 is positive, remember this is a negative 1, positive 1/3 x. Now let's go ahead and plug them in. We have our table, x and y. Our x values are negative 3, 0, 3, and 6. Let's do some substitution. We have y equals 2 plus 1/3 times negative 3. Again, always put it in parentheses. 1/3 times negative 3, positive times a negative is a negative 1. 2 minus 1 is going to be 1. So we get negative 3, 1. The next one, y equals 2 plus 1/3 times 0. Well, anything times 0 is 0. So we have 2 plus 0, which just equals 2. Then let's plug in 3. Y equals 2 plus 1/3 times 3. Remember, multiplying by 1/3 is same thing as dividing by 3. 3 times 1/3 is just 1. So we get 2 plus 1, which equals 3. 3 comma 3. Last but not least, plug 6 in. Y equals 2 plus 1/3 times 6. 6 divided by 3 is 2, so we have 2 plus 2, which gives us a y value of 4. So now let's just go ahead and plot these points. Negative 3, so I'm going to put my 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So we have negative 3, 1, 2, 3, up 1. So negative 3, 1's right here. 0, 2, 0, 1, 2. 3, 3, 1, 2, 3, up 1, 2, 3. And 6, 4. 6 up to 4. Now remember, you're done. You do not do it. It is a specific domain. Done. Think domain. Done. Don't. Connect. This is your answer. This is your graph. Let's go ahead and let's do another one. We again have a domain. So we know that it's going to be dots. Right away I'm going to think about that. Here my f of x equals negative x, so I don't need to do any rearranging. So let's make our table x, y, bring it down. We know x has to be negative 5, negative 3, 0, 3, and 5. Let's do some substitution. So we have f of negative 5 equals negative the absolute value, and I'll put it in parentheses, of negative 5. This negative right here, guys, it's super important. It's negative 1 times whatever we get. So we have negative 1 times the absolute value of negative 5 is 5, so we get negative 5. F of negative 3. Again, that negative, and I'm just even going to write it as negative 1 times the absolute value of, in parentheses, negative 3. Take the absolute value, we get negative 1 times 3, which equals negative 3. f of 0. f of 0, we get negative 1 times the absolute value of 0. Absolute value of 0 is 0. Negative 1 times 0 is just 0. Next one, f of 3 equals negative 1 times the absolute value of 3. Absolute value of 3 is just plain old 3, but it's times negative 1, so again we get negative 3. And one more, we have f of 5 equals negative 1 times the absolute value of my 5. Absolute value of 5 is 5. Negative 1 times 5 equals negative 5. It's an absolute value. Do you guys remember what this should look like? Should look like a V. Let's see if it does. We have negative 5. Since we're just going by ones, we don't need to put the label on there. So negative 1, 2, 3, 4, 5. Down, 1, 2, 3, 4, 5. Good. To the left, 1, 2, 3. Down, 1, 2, 3. 0, 0. To the right, 1, 2, 3. Down, 1, 2, 3. To the right, 1, 2, 3, 4, 5. Down, 1, 2, 3, 4, 5. It does look like a V, but it's upside down. This right here is actually called the vertex. This negative right here is what made it go upside down. And we were done because we were given a specific domain. It was dots. We cannot connect them. All right, guys, I would like for you to try all on your own number 3. Hit pause, and then I will go over the answer with you. Okay, your table after plugging it in should have been negative 1, 0, 1, 3, and 5. When you plug them in, you should have had negative 1, 8. Or I'm sorry, I'll just say what your y value should have been. Your y value should have gotten 8. And that looks like an 18. Get rid of that. 8. When you plugged in 0, you got 1. When you plugged in 1, you got negative 4. When you plugged in 3, you got negative 8. When you plugged in 5, you got negative 4 again. And again, I'll just go over one of those just in case you're wondering, maybe the negative. But f of negative 1 equals, in parentheses, negative 1 minus 3, quantity squared minus 8. You would first do your negative 1 minus 3, add the opposite, negative 1 plus a negative 3 is a negative 4. Keep it in parentheses, squared minus 8. Negative 4 quantity squared is 16 minus 8, which gives you 8. That's how we got that. So you would just have needed to do that for all of those. So when you plot it, you have your negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 1, negative 1, 2, 3, 4, 3, negative, okay, 2, 1, 2, 3, negative 1, 2, 3, 4, 5, 6, 7, 8, and 5, 1, 2, 3, 4, 5, negative 4, 1, 2, 3, 4. So you can start to see the U shape because you do have this exponent of 2 over here. But again, you have a domain, so it's just dots. So I bet you can guess what the next video is going to be. It's going to be when you don't have a domain. So go ahead to 4.4 part 2.